So today, we've done this before. We're going to talk about inverse relations and inverse functions. All right? Not everything has an inverse. So I'm going to take a look at example 1. And I'm going to go ahead and graph it with my pencil. Just watch. Don't write this down. It's going to look like this. 1, 2, 3, 4. Here. And you can check 1, 2, 3, 4. You can check it if you want to on your Desmos or whatever. But that's what the graph looks like, okay? Now, I talked earlier about the fact that if it has an inverse, it's going to pass the horizontal line test. Remember that? Remember the horizontal line test? So, if it has an inverse, it's going to pass the horizontal line test. So, this won't. And the reason it won't is because if we were to flip it, it's going to look like this. And again, I don't really need you to write this down, but it's going to look like this. It's not a function, agree? So this first graph does not have an inverse, right? But what I did is I put a little disclaimer up here. So okay, let's make sure that x is greater than -2. So really, from -2 to 4, the graph exists. So if I erase this half, then I can erase this bottom half, right? So this graph doesn't have an inverse, but if I take a look at this domain restrictions, what it is, then all of a sudden, the back half of the graph is gone, and I only have this part of the graph. Now you can graph this, okay? 1, 2, 3, 4, it goes right up there. 1, okay. So then, if I were to erase this back half, then this bottom half is there. Now, I just graphed it up there. How did I get that so quickly? Well, I've been doing this a long time, right? But if you're not sure how I got the green graph, what we can do is switch the points. Remember how we switched the points? So, to do an inverse, we're just going to switch the points. So, switch x and y to become y and x. So when graphs have inverses, the x's become the y's and the y's become the x, right? We've done this before. So if I were to take a look at the coordinates of these points, I've got a point at -2, 0. Am I going too fast? Yeah. So if I switch that around, I have 0, -2, right? I have a point at -1, 1. But if I switch that around, I get a point at 1, -1. Okay. I have a point at 0, 1, 2, 3, 4. So its inverse would be at 4, 0, right? 1, 2, 3, 4, 0. Okay, so there's my inverse graph, right? And then we learned before that it's a reflection over the line y equals x. All right, so let's take a look at what I have. So my original graph didn't have an inverse because it wouldn't pass horizontal axis. And thank you. So I got rid of the back half by restricting the domain. I changed the domain, so I only have it from -2 to 4. That makes sense? I got rid of the back half. So now this one does have an inverse because it will pass the horizontal line test. If I want to find its inverse graph, I just switch the points. -2, 0 is a 0, -2. -1, 1 is a 1, -1. A 0, 4 becomes a 4, 0, and there's my inverse graph. They are also a nice reflection over the line y equals x. Okay, we learned that before. So far, so good? Right. Now, to find this inverse equation, we're going to, again, switch every x and switch every y. So I'm going to go ahead and say it. Okay. So instead of y equals x plus 2 squared, we're going to write x equals y plus 2 squared. We're going to solve, right? So I switched my x's, my y's. Step 1, square root, square root, right? Square root, square root. Will somebody ask, please, hey, Mr. Davies, aren't there 2 answers because of the x squared, please?
Hey, Mr. Davies, aren't there 2 answers?
Technically, Zoe, you're right, because technically it'd be a plus or a minus. The square root of x equals a y plus 2. However, because we restricted the domain, right, didn't we? And we got rid of the negative half, it's really only just a positive square root of x. Thank you, Zoe. That was such a good question. Okay.
You're welcome.
And then finally bring over the subtract 2, and I'd have a square root of x minus 2 equals y. If we had the plus or minus, that's when we picked up the bottom half. Yeah. It would be the negative part of that. So then our inverse equation would look like this. F inverse of x is equal to the square root of x minus 2. And that is indeed that graph right up there. Okay, we did this before. Thumbs up?
Yeah.
1 thumb up, sideways, anybody? Okay.
Just kidding.
Okay, good.
I tricked you.
Now to verify their inverses. So how do you verify? They are inverses, but how do I verify it? So here's how we verify it. So if, you ready? Watch this. If f of f inverse of x
Move it down.
is equal to x.
Thank you.
Now you're going to learn this. And if, all right, here we go.
What is your
What?
Brandon, let's talk about that later, okay?
Well, what if I die like tonight?
You
That'd be
won't.
bad.
No, you won't. Okay, let's see what this says.
What?
If I take the inverse and plug it into the original, the answer should be x. If I take the original and plug it into the inverse, the answer should be x. This is the test that you'll do. Okay? So one more time. This is the test. How can I prove? Because in math classes, you're supposed to prove things. Eventually, you get high enough math and you're going to have to prove everything. Sorry. Luckily in here, you don't have to. Except for right now. How do we prove their inverses? So if you can plug the inverse into the function and get x, and if you can get the function into the inverse and get x, you'll prove that they're inverses. So what does that mean? Well, let's do this. Let's take my 2 functions. Here's my f of x is equal to parentheses x plus 2 squared, right? Here's my 2 functions. Let's plug the inverse into f first, okay? So let's do that first. So I would say, okay, the inverse is going in here, so I'm going to have a parentheses. I'm going to put all of this in for x. I'm going to take all of this and plug that in for x. I'm going to write this as a x square root of x minus 2 plus 2 squared, okay? I took the inverse and plugged in for x. I took the square root of x minus 2 and plugged in for x. Right there. You see that? Well, what do you see? Minus 2, right? Cancels, correct? And then I'm left with the square root of x squared squared, and that's just x. Well, that's what it was supposed to be. That's the proof. It's supposed to equal x. Boom, it does. Let me scoot it over so you can see it. It does equal x. Boom. Awesome. It was supposed to be there. Okay, now to prove it the other way, we're going to do just the opposite. I'm going to take my f of x, which is this one, and plug it into my f inverse. So I'm going to plug it right into there. Okay, let's see how that works. So, all right, let's try and do that. So I'm going to go square root of x plus 2 squared minus 2. Okay, one more time. Here's what I did. I'm taking now this equation and putting it right there. I took this equation, the whole thing, and put it in there. Okay? Well, what do you see? Square root and square cancels, right? You guys see that? So the square root and square cancels. So I'm left with a x plus 2 minus 2, which is x. Okay? You've proven it. This is pre-calc. And we proved. This is a math proof, proving that they are inverses. So if you plug the function into the inverse, you get x, and if you plug the inverse into the function, you get x. You've proven that they are inverses. Okay. All right, example 2. Thumbs up on the last one or sideways? Maybe sideways on the last one. Any downies? Okay, we'll keep practicing. Okay, all right. All right, example 2. Let's find the inverse. So what are you going to do?
Switch to X and Y's.
There you go. Aren't you guys glad Evan's here? Okay, you guys agree? Switch x and y's. So I've got an x equals a y minus 2 over a y plus 7. Capiche? So if I'm going to solve for y, I'm going to cross multiply. You guys okay with cross multiply? So if I cross multiply, I'm going to take y plus 7 up there and the 1 there. So I'm going to cross multiply. And I'll get x times a y plus 7 equals a y minus 2. I just cross multiply. Now I got to solve for y, but I'm getting there. Okay? All right, that times that makes an x, y plus a 7x equals a y minus 2. Okay? I'm going to solve for y, but I got too many y's. Just solve for y, but I got too many y's. So I'm going to put all the y's together. Okay, I'm going to bring this one over. And I'll bring the 7x
X, Y
over.
squared?
No, but you'll see.
Or
So I'm going to bring it over. So let me bring the y over. Let's bring the 7x over this side, and let's see what I get. So I'm going to bring it up here because I'm running out of room. Okay, I got an x, y, right? Minus y, because I had to bring that over, right? Equals a negative 2 minus 7x. Okay, here's what I did, so you guys can see it. I brought my 7x over here, and I brought my y over here. So now I got at least I've got to solve for y, at least I've got the y's together, right? I got too many y's. I'm going to put a 1 right here, and common factor. I'm going to common factor. What am I going to common factor? A y. Oh, I think I can solve for y now, can't I? Can I solve for y? Sure. Let's divide by x minus 1, divide by x minus 1, and what am I left with? Y.
2 minus 7x over x minus 1.
Yes. Oh, I just tricked you. What did I write instead?
Inverse.
Because that's what we're trying to, y is the inverse, right? Yeah, that's a good problem, huh? I like that one. Okay, ready to turn the page when you're ready? We're cruising, we're doing good. That was hard, right? Thank goodness I do the homework with you, okay? All right, example 3. Domain and range. Well, I can do that. Domain is, what's my domain? My domain is x equals everything except what?
Negative 7.
X cannot equal negative 7, okay? Okay, the range. Now the range. The range.
Reach for your range.
Okay, it will, okay, so if I reach for my range, this thing is going to be the kind of fractions we just did. It has a horizontal asymptote. Where's the horizontal asymptote at? Gobble, infinity.
1. I said it.
So, as x approaches infinity, we got infinity minus 2 over infinity plus 7. Right? Gobble, 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 gobble. Infinity over infinity is 1. So if it has a horizontal asymptote of 1, will it ever touch 1? It's never going to touch 1. So the range is everything up and down except, does that make sense? Because it's going, cruising, trying to hit 1, but it never can hit 1 until it gets to infinity. It's never going to hit 1, right? So my range is going to be y equals. So my range is my domain. My range is going to be y can equal everything except y will never equal 1. Because we gobbled up, we did the infinity minus 2 over infinity plus 7. When x goes to infinity, y goes to 1. Gobble, gobble, right? Okay, now, Domain and range of F inverse. Oh, we're going to make this so easy. We switch all the x's and all the y's. So if the x's become the y's and the y's become the x's, then we switch the domain and the range. Whoa, man, that just blew my head, huh? So that means the domain of this one is x equals all real numbers except for x cannot equal 1. And the range of this one means that y can equal all real numbers except for y cannot equal -7 because the x's and the y's switch.
Can it also, or the domain, can it also not equal 2?
0 on the top is
Okay.
good. See, such good questions because I want you to understand that, right?
Yeah.
0 on the top is 0, and 0 on the top is good. Okay, now, so are you ready? So the domain is the range of the original, right? So the domain is x equals all real numbers except for x cannot equal 1. That's my domain of the inverse. And my range is the domain of the original. So it's y equals all real numbers except y cannot equal -7. Awesome. Kind of makes sense to me. Because if the x is the y switch, then all of the x's switch with all of the y's, right? Including the problems. The problems also switch. Okay, now, last but not least, Mr. Massey said, please teach them completing the square. All right. Y equals x squared plus 4x. Okay? We did this last year. What's half of 4?
2.
What's 2 squared?
4.
Okay, do you remember doing that at all? Completing a square? 1/2 of b squared. So let's do it again. What's half of 4?
2.
So half of 4 is 2, and then 2 squared is what? 4. So, but if I add 4 to this side of the equation, okay, equal signs keep things balanced. I just stuck 4 pounds on this side. What do I have to do to keep it balanced? So I better add 4 to the other side. Okay, so I'm going to go, okay, y plus 4 to keep it balanced. Okay, so I'm going to rewrite my equation as a y plus 4 equals an x squared plus 4x plus 4. Okay, now why would I even do that?
So that you can take your...
This will factor. This will factor. And if I factor this, it's going to become a problem like this, which we just did, right? It's going to become a problem like this. So if I factor this, factors into an x plus 2, x plus 2, or x plus 2 squared. You get that? So I haven't done anything to get an inverse, but what I've done is I set myself up to get the inverse equation easily, okay? Because what I've done now is it's going to be like one of these. And that wasn't too hard to solve, right? So what do I do to find the inverse? Let's switch my x and y's. So let's go x plus 4 equals y plus 2 squared. And let's solve. First step, square root, and we're not going to do a plus or minus because I told you to make sure you keep it positive, right? So square root. So I'll have a square root of x plus 4 equals y plus 2, and then?
-2.
Yeah, so f inverse of x is equal to the square root of x plus 4 minus 2. That's my inverse equation. Okay, that's all I have. And I don't have a lot of homework.